So hi friends. Once again, greetings of the day. And now we will see the answer for the part two questions. Okay. Next is first one is eighth question is first question of this part two. Obviously, it's the eighth question of the overall. As per Shannon's capacity theorem, capacity could be enhanced. This we have discussed some time back. So one is increasing the operating bandwidth, obviously, because when you increase the bandwidth, then obviously the throughput is directly proportional to the bandwidth. Next is number of RX antennas, because though a base station has many options that it can send the data, like but your user should be able to get that. Should be have a sufficient resources to get that. So that's why therefore the number of RX antennas also matters. It can be 2 cross 2 MIMO or 4 cross 2 4 cross 4 MIMO, so many more. Okay. Next is SNR. Obviously there sometime back we have discussed. So the answer is ABC, which is E. Okay. Next is sub 6 GHz band frequency range as per 3GPP spec. So as I mentioned many times during my presentation on 5G OTA and spec and all. So the now sub 6 gigahertz is no more only below sub 6 gigahertz. It's been updated in the spec that 410 megahertz to 7125 megahertz. So that we have to make sure. Okay. So when we talk of hereafter, when we talk of sub 6, which refers to up to 7125 megahertz. Okay. So higher subcarrier spacing are used for low latency communication. Of course, it's true. Why? Because when you use higher subcarrier spacing, then your slot time will be in microseconds. Okay, not even microseconds. 32.5. For example, if you are using 240 kilohertz, then I think 32.5 microseconds will be there. So that's why we go for higher subcarrier spacing for low latency communication. Next is in MMTC, which subcarrier spacing is widely used, because 15. Okay, so MMTC the mainly you would not require higher data rate most of the time. Okay, for example, in some application of course it may require, but widely most of the application will not require very much data rate, because for example EB, smart grid and other things. So it require very, if you can give very low, because you can't afford to give them very high data rate. So that's why you can say that okay, 15 kilohertz is most widely used. Okay. Next is which one is not a correct interband NR combination. Okay, so there is NR combination like FR1 FR2, there is a carrier aggregation bands are specified in the spec. Okay, that so you can in FR1 and FR2 you can have a few band combinations. That is due to various reasons, like antenna design is involved, so many RF front end design is involved. So you can't have both the bands simultaneous subsequent bands. You can't have for example one band is in you can't have a, for example in sub 6 you have one FR1 we have one band. So in FR2 you can't have a subsequent harmonic band. So because it will become a problem, because for example if you are having 5 gigahertz in the FR1, so you can't have 25 gigahertz or 30 gigahertz in the FR2, because the problem is harmonics will come into picture. That could be the reason. So it's my guess. Okay, so that's why they arranged carrier aggregation bands in such a way that the both the communication, both the bands carrier aggregation will go smooth. Okay. Next is FR2 frequencies are also called as millimeter wave frequencies. Since its wavelength is in millimeter. Okay, that's why. That's it's a straightforward question. Next is what are beam process happen when beam process or procedure happens when UE connect to the network. So apart from catching up synchronization signals and SSBs from the SSBs block reading and other things. So what it does is beam first initially what it does is UE try to acquisition beam acquisition will happen, because based on the primary synchronous signal, and then it will update this channel state information to the through channel state reference signal, that so I could capture the particular beam acquisition and then track. So when UE is in movement mode, so One more thing is that SSB block will have 20 millisecond. It will always sweep. Every 20 millisecond it will always sweep the beams. Okay, so if any UE is there or not. So if some UE is there, then it will try to acquisition and track that UE, and then what it does is based on the channel state information, it will keep on update refine the beams towards that particular UE. So meanwhile, it will also gets a feedback from the UE that so what sort of beam, whether you are using complete beam or not. So beam it's basically beam peak search. Okay, so it will happen only if beam feedback is properly obtained. Otherwise, you can't. So not the last one is gain tracking is not the answer. So that the answer is F, A, B, C. Next is different beamforming techniques is obviously analog, digital, and a hybrid. This we have mentioned many times. Each one has its own advantage. Analog has certain advantages because you can use one subcarrier spacing, but it's very much cheaper, and because do not have a complex hardware. But digital has more flexibility, like you can use at a time, you can use flexible subcarrier spacing. So therefore the digital will be fine, but the problem is hardware complexity. So that's why they go for hybrid, because they're making use of advantages of both analog and digital. So in analog, so each branch will be you will fed as analog, and then each branch will be I think from digital it will, each branch will be processed as analog, so that you can have a hybrid beamforming. So thanks for that. Okay, next we will see part 3 next video. Thank you.